Let's investigate the decay of the T quark. First, we have an ordered pair 1/2, 2, representing the T quark, giving the Rishon assembly a U quark and a dual relating boson 0. We can see over here graphically, though, that the D quark will be actually composed, that the U quark here will be actually composed of a D quark and a boson plus. And in addition to the boson plus, then we have the dual relating boson 0. So, in the decay process, we will have the boson plus interact with a pair of outer relating Rishons. And so the outer relating Rishons interact with the boson plus and form a boson 0 and another boson plus, except this boson plus will then also interact with this boson 0. And that interaction will create Higgs-like boson 0 here and a W boson here. And after the emission of this Higgs boson and this W boson, we will be left with a D quark and a boson 0 forming a B quark, which is represented over here by the ordered pair 0, -1 and this assembly with a D quark and a dual relating T Rishon, represented here and here, and the emitted W boson. The emitted W boson will interact with an electron anti-electron pair and a pair of self-relating V Rishons. The electron will exchange its self-relating anti-T Rishon with this self-relating V Rishon. And this dual relating V Rishon will take the place of that self-relating V Rishon. These exchanges will leave a neutrino and an anti-electron in place of the W boson particle, and the emission of a weakly interacting massive particle candidate, as well as a self-relating Z boson 0. As we can see over here, these changes are represented by here being the neutrino, which we can see the assemblies that represent the electron and anti-electron, and with the self-relating V Rishon replacing one of the T Rishons, negated by this T Rishon. We will have the the neutrino here, and here we will have one of the T Rishons of the antineutrino negated by an anti-T Rishon and replaced by a self-relating T Rishon, as you can see over here graphically represented. These three particles that are emitted are represented by the ordered pair 4/2, 0, and this assembly. So, in summary, if we start off with a T quark composed with a D quark and a boson plus and a boson 0, then in two stages there would be the emission of W bosons, or boson plus. The first emission will leave you with a D quark and the boson 0, which is the B quark, part of the decay. And then a W boson will farther be emitted and decay into a neutrino and an antineutrino and a WIMP candidate and a Z boson.